So in the series of classes about modeling stochastic processes and application to computational biology, I would like today to introduce the first class. This is really a preliminary introduction about dynamical systems. And so I would like to introduce what are dynamical systems and give really preliminary information about them that we will need. So the plan of the class is going to be the following. I would like to start from dynamics of forces of Newton's law of motions and the idea of how to integrate equation to have access, to understand, to have information about what a trajectory is doing. And then, of course, because we don't know necessarily what's going to be the future of a trajectory, I would like to introduce notions of dynamical system which are called a recurrent set, which is the place where we can see a trajectory. And finally, I would like to present some very simple introduction about bifurcation theory, which is important to understand how a dynamical system changes when a parameter or a set of parameters is changing. So from forces to dynamics. So let's start. So you all know that Newton's law of motion relates the forces to acceleration. That is, if we know the ensemble of forces applied to a point, then we know the acceleration, the second derivative of x. X is the position at time t. And so what is the meaning of integrating such an equation? Well, this has been well formulated in a couple of years ago, 100 years ago, by the Cauchy problem. And so the Cauchy problem goes as follows. If we know the position of the particle at time 0, and if we know its velocity, the idea of the theorem, so if this is x0, this is a velocity v0, and then equation 1, based on this condition, can be integrated and has a unique trajectory. So this is the starting point of the classes of today. So how do we integrate this equation? What is the meaning of integration? And we will see that most of the time it's not possible to integrate this equation. And so we would like to see alternative methods, and the alternative methods are coming from dynamical systems. So I may also, why we want to do that in the context. So in the context of the classes, in our class of stochastic equations, is that if you remember, or we will see in the future, if we have what is called the Langevin equation, where you have the mass, the acceleration, plus the friction term, which is gamma multiplied by the velocity, plus some forces, equals the stochastic processes. So we have here a constant. It's exactly 2 epsilon gamma. Well, I will discuss later on what are those constants, and this is a noise. Then really the dynamical system corresponds to the case where this is 0, and for example, we don't have this term here also. Still, we are interested in understanding how forces determine the motion. So this is for the general introduction, why we need to do this. So let me formulate the basic question of integrating a dynamical system. So first of all, what this is about. So suppose we have an equation of the form x dot, which means dx dt, equals b of x. Or b of x is a vector field. So you all know what is a vector field, right? You have an ensemble of vector, as shown in here. So you see small vectors that are here, there. So they form a continuous field, so that b of as a function of x is continuous. It can even be more regular. And so the general question we will be interested in, which is to solve equation 2. And what does that mean? It means, can we find, let's say, let's give a starting point x0. So we start, let's say, somewhere here. This is x0. Can we find a continuous trajectory x of t such that x of 0 equal x of t at 0 equal x0, and such that it satisfies 2. What does that mean? It means that the tangent at each position equals b of x, which means that if we start here, the trajectory should be such that at each point the vector field corresponds to its tangent. As we see here, this is a tangent at any point x of t. So the answer to this equation, question, is called the Cauchy theorem, or the generalized Cauchy theorem, which I'm not going to prove in here because this is really these classes correspond to an introduction to stochastic processes. So I want to give here the basic introduction for dynamical systems based on a known theorem, so that it is your responsibility to go and to look at this well-known theorem, which I think is part of undergrad studies. So Cauchy theorem states that if b of x is sufficiently continuous and regular, then we can always find an interval a such that so then there exists I, which is an interval such that such that we have a solution. So x of t, there exists a solution x of t of equation 2, and satisfying x0 equal 0, and this solution is unique. All right, so this is the statement of Cauchy theorem. So before, I think we are going to break here for the first part of the class before going to the basic properties of a dynamical system. So then I'll see you in the next class for the discussing basic property near recurrent sets.